Okay, example 4 has us trying to find an orthocenter on the coordinate plane. So it's asking us to find where do those three altitudes meet up. Now, I will tell you, after quite a bit of searching online, I could not find a single clear example on what an orthocenter is used for. So I will ask around in the math department. I will see if there's anybody wiser than me who knows a good answer to that. Why do we want to know about these orthocenters? For me, I don't know why. So I'm going to skip this example. It's a little long and bit difficult anyways. So we're going to just kind of wrap up with this vocabulary idea of just what this thing is called, the altitude. And like I said before, it's basically just the height of the triangle, depending on which way you're facing. I will pause for a moment to go over some math history. So this guy on the sidebar, it says Pierre de Fermat, who lived from 1607 to 1665, about 400 years ago, was a French lawyer and mathematician who is considered to be one of the greatest mathematicians of the 17th century, so of that century he lived in. He is best known for his last theorem, which wasn't proven until pretty recently, 25 years ago, 1995. 3 years after I was born. So 400 years went by, and then somebody proved his theorem correct. Now, Fermat's last theorem that they're describing here, kind of, when I looked it up, I would sort of connect it to a squared plus b squared equals c squared. So when we say a squared plus b squared equals c squared, we are specifically talking about right triangles. Now, there are certain right triangles, like a 3, 4, 5, which have whole numbers for each of these three. So it is possible for an equation that says a squared plus b squared equals c squared to be answered with only whole numbers. Like we could have, like I said, 3 squared plus 4 squared equals 5 squared, all whole numbers. As you've seen before when doing right triangles, you don't always have whole numbers. Okay, it's not necessary that you have whole numbers, but it is possible. Now, what Fermat's last theorem said was that if you were to try to explore these types of equations, and instead of doing squares, do any other number, cube to the 4th power, to the 5th power, to the 6th power, there is no numbers that I can put in. So like, let's say I do, 3 cubed and 4 cubed. There is no whole number here that I can put in. Okay, 3 cubed plus 4 cubed is not 5 cubed. It's not 6 cubed. It's not 7 cubed. Okay, it's some sort of, decimal point. And so Fermat's overall idea was that you will not find whole number solutions to this equation unless you're looking at the one that we're the most used to, the one that has exponents that are the squares. Okay, now that goes on and has interesting kind of ramifications that we won't get into right now, but just sharing a little bit of famous mathematician. If you spend some time in math, just kind of like listening, interested in the subject over the years, I've heard this guy's name all the time. Specifically, Fermat's last theorem, I've heard that brought up quite a bit. Okay, so I think that's kind of it. So in review, you want to know the altitude of a triangle. It's just kind of a common vocabulary term. And you want to know how to find the centroid. Finding the centroid is the one with the most practical applications that I can think of, mostly related to sort of those finding the center of mass. So anytime somebody's building something and they want it to be balanced, you have to locate the center of mass. And if you're dealing with triangles in your building shapes, then you want to know how to find the center of mass of those triangles. So once again, to review that, we take a vertex, we go across to the midpoint of the other side. We do that from each vertex, and where they cross over is that center of mass. Okay, so that's kind of our main ideas for lesson 6.3, medians and altitudes of triangles. Hope that all makes sense. I wish you luck on your homework for this one and for any assessment that you have over this week's material. All right, I'll catch you next time.